So we'll run briefly through these two examples, and we'll show that the rule will work for the situation, but we can also kind of map it out and do it the long way. So a coin is tossed, and a regular tetrahedron labeled 5, 6, 7, and 8 is rolled. We can see kind of what that looks like. What's the probability of tossing heads? So for A, tossing heads is 1 out of 2. Rolling an 8, there's 4 options on the other dice, so it's 1 out of 4. Multiply those probabilities, 1 out of 8 is your answer there. Okay, it's as simple as that. It's actually pretty straightforward, and this is nice, especially as our numbers get bigger. Find the probability of tossing heads or tails. So heads or tails, it's technically 2 out of 2 or just 1. Okay, and then we multiply that by rolling an even number. Well, 6 and 8 are even, so 2 out of 4 are even. So this is just 1 times 2 over 4, which is just 2 over 4, or 1/2 of the possibilities. Okay, so I can quickly just draw up a table here where I could show heads and tails are my options, going with 5, 6, 7, and 8. So you could get heads and 5, heads and 6, heads and 7, heads and 8. Or tails and 5, tails and 6, tails and 7, tails and 8. So you can see there's 8 options there. So if I'm looking at the first one, again, tossing heads and rolling an 8, there's only one that has heads and 8. Okay, if I was doing the second one, what's the probability of tossing heads or tails? It doesn't really matter. All we're looking for is an even number. Well, this one has heads or tails and an even number. This one has heads or tails and an even. This one. So that's 4 out of 8, which is, in lowest terms, 1 out of 2. Okay, so that rule is backed up by actually working through it and figuring it out. Okay, so there you can check in your book and you can see that these answers make sense as well. Okay, this one we start to get into bigger numbers. We have a bunch of tees in a golf bag, so 9, 7, 4, so that adds up to 20 tees altogether. Okay, golfer takes one out of the bag, looks at what color it is, and then puts it back in. And then he does it again, pulls another one out. So these two events are independent, because what he does in the first one doesn't affect because he puts it back in his pocket. If he would actually pull it out of his pocket, now these events would slightly change, and we don't really deal with that in grade 8 yet, but they could kind of change. We'd actually call them dependent events, but we're not going to worry about that right now. Okay, so what's the probability of both tees being read? So we just have to basically find the probability of being read once and then doing that again. So there's 20 tees, 7 of them are read, so the first event is pulling one out of your pocket. There's a 7 out of 20 probability that you pull out a red tee. You put it back in, so there's still 20 tees in there, and the probability of picking out a red one. You can multiply the tops, multiply the bottoms. Now again, with probabilities, you can report them as a fraction. You could just leave it like that, but you could also do 49 out of 400, which would give you the decimal form. So probabilities can be actually given as decimals as well, which is 12.25 as a percent. Often we see probabilities given as percents as well. So if it doesn't say, you can just do whichever one makes the most sense. I typically just have you leave it as a fraction. Okay, that's for A. For B, the first T is not red, and the second T is blue. So not red, we're basically looking, what's the probability of not getting a red? Well, that'd be 9 and 4. There'd be 13 other T's that are not red. Okay, the second event is that it's blue. Blue T's being 4 out of 20. Now, you can just multiply tops, multiply bottoms, but it's nice if you just put this in lowest terms. 4 out of 20, you can actually cancel that out. You can divide both sides by 4. You could put this into lowest terms, in other words. What this does is it basically simplifies before we actually make the calculation. It makes the calculation a lot easier to make, actually. Okay, so 13 out of 100, or 13% actually. Okay, so it's not like you have to. You could just multiply and then simplify it further, but typically you will be asked to put these fractions into lowest terms, so it's a good habit to get into, that we simplify as we go. Okay, so that's the basics of probability for independent events. you can practice some of these questions on page 411.